So this is the second problem of CMI paper 2021 of paper 1. So in this uh, we have to deal with prime numbers and the properties they follow. So a statement is given upon a definition of prime number p is given there, and for the four statements ABCD we have to identify whether they are true or false. Okay, so let's talk about statement A. So it says that for any prime p the number p square minus p is always divisible by 3. So let's talk about that. So we can see that if p is greater than, given that p is greater than equals to 2, so p square minus p means p square minus p is actually equals to p into p minus 1. Okay, so if you put 2 here, because p is greater than equals to 2, so if you put 2 here, this is 2 into 1, that is 2, and certainly this is not divisible by 3. So when the statement said that it is always divisible by 3, so statement A is a false statement. Okay, but we can think it in another more general terms. We know that any prime number that is greater than 2 can be expressed in this form, 6n plus minus 1. Okay, can be expressed in this form. So if we choose a number that is p square minus p, let's call this is p. Okay, then p square minus p means that p into p minus 1. Okay, so this is 6n plus minus 1 into 6n plus minus 1 minus 1. Now we have two cases here. This will be 6n plus minus 1, and we'll open it with once plus and the second time with minus. So this will give us 6n plus 1 and minus 1, that is 6n, and the second case would be 6n plus minus 1 into 6n minus 2. Okay, now here we can see that this is divisible by 3. Okay, this is divisible by 3, but here neither this is divisible by 3, neither this is actually divisible by 2. Okay, so and it says that it is always divisible by 3, which is not followed in the second case. Therefore statement A is incorrect statement, that is a false statement, which we can simply identify by putting values, but this is a more general term. Okay, now let's talk about statement second. I'm gonna rub this for more space, but must keep in mind that any prime number greater than equals to 3 greater than the 2 can be expressed in this form. This is very important form, and this will actually help us a lot. But here we are going to just use hit and trial. So for any prime number greater than 3, exactly one number p minus 1 and p plus 1 is divisible by 6. Okay, so this is p minus 1 and this is p plus 1. Okay, now p will be in between this, and these are actually 3 consecutive integers, positive integers. So any one of them would be divided by 3. How so? Because you take any 3 positive integers, then any one of them would be divisible by 3. For example, 7, 8, 9. 9 is divisible by 8, 9, 10. 9 is divisible. 13, 14 and 15. 15 is divisible. So any 3 positive numbers, integers, are divisible by 3. So in this, any one of them would be divisible by 3, but this is a prime number, so it is not divisible by 3. So any one of these two, any one is divisible by 3. And since p is a prime, therefore it must be odd, because it can't be even, because if it is even then it's not a prime. So p is odd number, so therefore p minus 1 would be even. So p minus 1 would be even, and p plus 1 would be even too, because odd minus 1 is even and odd plus 1 is even. So and any one of them is divided by 3, but both of them are divided by 2, therefore any one of them is divided by 6. Okay, so statement B is also true. Let me explain it once again. Since p minus 1 and p plus 1, any one of them is divided by 3, but the both of them, this is also divided by 3 and this is 2, and this is also divided by 2, but any one of them is divided by 3. So the one which is divided by 3 and divided by 2 is actually divided by 6. So that's statement C. Now we have to talk about statement, sorry, that's statement B. Now we have to talk about statement C. For any prime p greater than 3, the number p square minus 1 is divided by 24. So we can actually think about this, that p square minus 1 we can write as p plus 1 and p minus 1. Okay, this is divided by 2 because p is p is a prime, so it must be odd. So odd plus 1 is even, so this will be divided by 2. So I'm writing it this in the form of 2k. Okay, this is again even number, so I'm writing it in the form of, let's say, 4k. Okay, and so this whole thing is actually divided by 8 because it is divided by 4 also, it is divided by 2 also. And we also know that in the above in the previous statement B, we proved that any one of these two is divided by 3. So any one of them is divided by 3 also, therefore it is divided by 24. Why so? Because it is divided by 8 because of these two, and any one of them is divided by 3, so it is divided by 24. So statement C is also true. Now let's talk about statement D. In statement D, we can see that for any p greater than 3, one of the three numbers p plus 1, p plus 3 and p plus 5 is divided by 3. You can simply do that experiment with this form 6n plus minus 1, and you add plus 1 here. So you are left with two cases, that is 6n or 6n plus 2. You take 6n plus minus 1 again, and you add plus 3 here. Then again you are left with two cases, that is 6n plus 4 or 6n plus 2. Okay, you take another case, that is p plus 5, that is 6n plus minus 1. Okay, and this is plus 5. It again leaves you with two cases, that is 6n plus 6, and this is 6n plus 4. Okay, now we can see that it says that it is divisible by 8. So neither this is divisible by 8 nor this is divisible by 8. Here also neither this is divisible by 8 nor this is divisible by 8. Here also neither this is divisible by 8. This is actually divisible by 6 only, and this is also not divisible by 8. So statement D, we can see, is also incorrect statement. So only statement A and D are incorrect. Rest B and C are true statements. So that's CMI 2021. Second problem. Let's talk about problem number 3. And I assume that my series of PYQs of CMI, J Advanced and ISI is helping you. So please like, share and subscribe. Thank you.